This is section 1.5, linear equation word problems. So this section is basically nothing but word problems. So our first thing is we want to be able to translate English into algebra. So translating English into algebra. So in each case we'll list the most common words or expressions that have a particular algebraic meaning. Keep in mind that it will be impossible for us to list all words or phrases. Just like it's going to be impossible for us to do all types of word problems. You have to be here till the end of time. It will be impossible for us to do every type of word problem you might ever encounter. All we can do is give you some basic tools and principles, and it is up to you to apply them to each situation. So the following phrases mean addition. Okay, add, it's like, add John's age to Mary's age. Sum, that is the result of an addition problem. Increase by, more than, greater than. Total or totals to, and then we have the comparisons, older, taller, longer, heavier. So we'd like to get similar phrases for subtraction as well. So the following phrases mean subtraction. Subtract, subtract A from B. Difference, difference is the answer to the subtraction problem. Decreased by, less than, less, fewer, younger, shorter, and lighter. Okay, I've put asterisks by less than and less because those are the ones that are more commonly used. They do mean two different things. Less than is different from less. Now when you're adding, the order in which you add doesn't matter. Remember the commutative property. 5 plus 7, 7 plus 5, same thing. But when you're subtracting, 7 minus 5 and 5 minus 7 are not the same thing. So, less than versus less. Now again, between the two, less than is more common than less. A less than B means B minus A. Okay, so A less than B means B minus A. Number 2, A less B means A minus B. Notice the word than has made you subtract backward from the way the letters are given to you. So A less than B is B minus A. A less B means A minus B. So if you see the word than in the problem, do the operation backwards from the way it is written in the problem. Addition does not matter, but subtraction requires it. That way you will be consistent. By following the above convention, we will be consistent with addition and subtraction, and we will get the subtraction correct. Because remember, if you subtract backwards, it doesn't matter what you do after that, it's already wrong. Okay, the following phrases mean multiplication. Okay, multiply, multiply John's age by 3. Product, product is the answer to a multiplication problem. Times, as in John is 5 times older than Mary. Twice means 2 times. Double also means 2 times. Triple is 3 times, as in, we have tripled John's age. Of, especially with fractions and percents. If we say take 25% of something, that means 25% times it. And then as much as great as, and as long as. 2 occurrences of the word as means multiplication. It may not sound like it, but it does. And then the following phrases mean division. Divide, a quotient. Quotient is the answer to a division problem. Split, as in let's split the cost. Share or shared, and halved means to divide by 2. Now the reason there are so few phrases for division is because division is multiplication by a fraction. So dividing by n is the same thing as multiplying by 1 over n. And we have the word of for multiplication by a fraction. That can take half of the cost. So that means take the cost and multiply it by half, which is the same thing as dividing the cost by 2. Now the one thing we have missing is what means equals. So the following phrases mean equals. Verbs of being. Is, was, were, will be, must be, could be, should be, has to be, and so on. Those mean equals, as in 2 plus 3 is 5 is the same thing as saying 2 plus 3 equals 5. Remember, all English sentences have to have some sort of a verb, and oftentimes the verb of being is used as the verb in a sentence. So be sure you can distinguish between a verb of being for the verb of a sentence and the verb of being for the equal sign. So as soon as you've identified the verb of being that means equals, what came before it is the left side of the equal sign, and what comes after it is the right side of the equal sign. Now note, we do not have any words or phrases for parentheses. Parentheses are indicated by inflection, tone, or a combination of all of the other words and or phrases. It's kind of up to you to recognize by how the statement is given whether or not you have some parentheses. Let's try some examples. Let's translate each English sentence into an algebraic expression. Make no attempt to simplify or solve. This is the one and only place where we do not simplify anything, we don't solve anything. Now it is just going to be an expression. There is no equal sign. Here are our problems. Okay, the first one says 5 more than x. Now remember, if we see the word than, we're going to write it backwards. The more is addition, so it's x plus 5. Okay, 5 plus x is okay, but x plus 5 is preferred. Okay, 7 less x. Okay, I don't see the word than, so you have to write it as 7 minus x. No choice. Number 3, 3 less than x. I see the word than. You have to write it backwards from the way it's given to you. It's x minus 3. Number 4 says 2 more than twice the sum of x and 3 times y. Okay, I've got 2 more than, so I've got plus 2 on the end of something. I want 2 more than twice the sum of x and 3 times y. This little phrasing says that x plus 3y is in parentheses, and twice means 2 times. So I'm going to have 2 times, and in parentheses, x plus 3y plus 2. Number 5, 10 less than 3 times the product of x, y, and z. Okay, I have 10 less, so 10 minus something. 3 times the product of x, y, and z. So the product of x, y, and z should probably be in parentheses. So 10 minus 3 times x, y, z. Now you can actually drop the parentheses because it is all multiplication. You're not doing any sort of distributing, so you can in fact drop it. Now going back to number 4, don't distribute. Remember, make no attempt to simplify or solve. Number 6 says twice the sum of 3 and 15. So I got 2 times something. Sum of 3 and 15 goes in parentheses. So 2 times 3 plus 15. And again, make no attempt to simplify or solve. Okay, don't do the arithmetic. Number 7 says 12 less 2/3 of x. I don't see the word than, so it's 12 minus 2/3 times x. So 12 minus 2/3 x. Number 8, 4 more than half the sum of 10 and 9 times x. So I got 4 more than something, so I'll have plus 4 on the end. I want half the sum of something, so 1/2 outside parentheses, and inside 10 and 9 times x. So 10 plus 9x. So 1/2 times 10 plus 9x plus 4. And again, don't distribute. Again, you're not making any attempt to simplify or solve. Let's now try doing some word problems. So again, it's impossible for us to go over every type of word problem you might ever encounter. Okay, you'd have to stay here for forever. Fortunately, many of our word problems fall into categories. We will take a look at some of those categories. On tests and homework, or even on quizzes, getting or not getting a particular word problem or type of word problem is simply a matter of luck. Several versions of each test and the final exam have been prepared. It is simply the luck of the draw as to which problems you get. The same thing applies to the homework and the quizzes. There is more than one version of each particular homework assignment, and there's more than one version of each particular quiz. So you may get word problems that you hate, you may get word problems that you actually enjoy. Now, the number of categories that we have, let's see. We're going to be looking at 9 categories of word problems. Number problems. Okay, now sometimes when you're doing word problems, you get an answer to the equation, which is fine for the equation, but it does not make sense for the word problem. Like you can't have negative lengths, you can't have negative area, you can't have negative widths, and so forth. With the number problems, whatever comes out is actually going to be acceptable. So we look for a number that satisfies certain conditions. Now, you may not like getting a fraction as an answer, but it's okay. So some examples. Our first one. 6 more than 3 times a number is 15 less than half of the number. Find the number. Again, I got 6 more than 3 times a number is 15 less than half of the number. We're going to find the number. For lack of a better name, let me call the number x. So again, I'm looking for 6 more than 3 times a number is, okay, there's my equal sign. So 6 more than 3 times a number, 3x plus 6 equals, okay, 15 less than half the number, 1/2 x minus 15. So this is where everything is coming from. Okay, notice our equation really isn't bad. We've had worse equations back in section R.5 when we're solving equations. So again, this is where everything is coming from. Okay, if we get rid of the color, there's our equation. Now again, I see a fraction. Myself, as soon as I see a fraction, I want to clear fractions. The common denominator is 2. It's the only denominator we see. So multiply everything by 2. I'll get 6x plus 12 equals x minus 30. I want my x's to the left, numbers to the right. So subtract x, subtract 12. I'll have 5x equals negative 42. Divided by 5. So x will be negative 42 over 5. That's our number. The number is negative 42 over 5. Hey, don't go to a decimal, don't go to a mixed number, it's not worth the effort. Let's try another one. I have 5 less, 7 times the number, is 2 more than the number. Find the number. So 5 less, 7 times the number, is 2 more than the number. Find the number. Okay, again, for lack of a better name, let's call the number x. Here is our verb of being that means equals. So 5 less 7 times x. So 5 minus 7x equals x plus 2. Again, here's where everything is coming from. Remember, if you don't see the word than, write it down exactly as you do see it. If you do see the word than, write it down backwards the way it's coming to you. That's why I've written x plus 2 instead of 2 plus x. Okay, if we get rid of the color, here's our equation. 5 minus 7x equals x plus 2. Now again, I want to move x's to the left, numbers to the right. So subtract x, subtract 5. I'll have negative 8x equals negative 3. Divide by negative 8. So x will be 3/8. That's our number. So there are the number problems. Our next category of word problems, consecutive number problems. Okay, consecutive number problems. Okay, consecutive means one after the other. Consecutive numbers must be integers, even if the problem does not say the word integers. There's no such thing as consecutive fractions. I mean, there's no such thing as the fraction after a half. I mean, there are a bunch of fractions after a half. But consecutive integers, like the integer after 1, that would be 2. The integer after 3, that would be 4. So this means that consecutive number problems can have no solution. Like if you do all the work and you get up with something, and you end up with something that's not an integer, and you've not made any mistakes, that means there is no solution. Now, if that really does happen to you, you go through all the work and you get something that's not an integer, I would go back and check my work before I wrote down no solution. So 45 and 46 are consecutive integers. They differ by 1. Okay, consecutive integers differ by 1. 42 and 44 are consecutive even integers. Notice, they differ by 2. 51 and 53 are consecutive odd integers. They also differ by 2. Consecutive even and consecutive odd behave the same way. They differ by 2. So, number 1, consecutive integers differ by 1. They look like this: x plus 1, x plus 2, x plus 3, and so on. You add 1 every time. So the above would be 4 consecutive integers, provided the first one, x, was an integer. If the first one is not an integer, none of the others are either. Okay, now remember consecutive even. Consecutive integers differ by 2. They look like this: x plus 2, x plus 4, x plus 6, and so on. You add 2 every time. The above would be 4 consecutive even integers, provided the first one, x, was even. Like if x was 4, x plus 2 would be 6. X plus 4 would be 8, and so on. Now notice if you start off with an odd one, then they're all odd. So number 3, consecutive odd integers differ by 2. They look like x plus 2, x plus 4, and x plus 6. Again, you add 2 every time. So the above would be 4 consecutive odd integers, provided the first one, x, was an odd integer. Like if x is 3, x plus 2 is 5, x plus 4 is 7, and x plus 6 is 9, and so on. So notice when you set up the consecutive even and the consecutive odd, you're going to set them up the same way. So if you see the word even or odd in the word problem, you'll add 2 every time. If you don't see the word even or odd, you're just going to add 1 every time. So, excuse me. Let's take a look at some word problems with consecutive numbers. So, some examples. Okay, number 1 says, find 4 consecutive integers that satisfy the property that the sum of 1 more than 3 times the second integer and 5 less than twice the third integer is 69 less than twice the sum of the first and fourth integers. Okay, kind of a weird relationship here. So I want 4 consecutive integers that satisfy the property that the sum of 1 more than 3 times the second integer and 5 less than twice the third integer is 69 less than twice the sum of the first and fourth integers. Now again, the first time we read the problem, I just want to see, does it contain the word even or odd? Find 4 consecutive integers. It doesn't say even or odd. So I'm going to add 1 every time. So for our solution, x will be the first integer. Then add 1. X plus 1 is the second integer. X plus 2 is the third integer. And x plus 3 is the fourth integer. Just add 1 every time. Okay, now, here is our verb of being. Now notice, except for the first integer, all the other integers have some sort of operation with them. You need to keep these guys in parentheses. Okay? So there's our verb of being. Now, here's where everything comes from. This is the plus sign for where it's sum. One more than 3 times the second. Okay? There's one more than 3 times the second, where the second is x plus 1. Okay? 5 less than, so there's my 5 less than, twice the third. The third one's called x plus 2. 2 times x plus 2. Okay, there's my equals, twice the sum of, so I need 2 times something. The sum of the first and fourth. Okay, 69 less than, there's my minus 69, twice the sum of, so 2 times x plus 3. Okay, so we have a rather long equation. Now, just a bit of information here. With the consecutive number problems, the very first equation you write down typically will be long. Not difficult, but long. The second equation, after you start doing a little work, is also typically very long. It's not until about the third and sometimes even the fourth derived equation that it starts to look kind of nice. So again, this is where everything comes from. Let's get rid of the color and start working on the problem. Okay, as I start working on the problem, I should distribute this 3, distribute that 2, and inside the brackets, I can combine x plus x to get 2x. So I'm going to have 3x plus 3 plus 1 plus 2x plus 4 minus 5 is equal to 2 times 2x plus 3 minus 69. Okay, on the right, I will distribute this 2 outside the brackets, and on the left, I can combine some similar terms. 3x and 2x will be 5x, and for the number, 3 and 1 is 4, plus 4 is 8, minus 5 is 3. So I'm going to have 5x plus 3, so again, that's what I'm combining, the x's and the constants. 5x plus 3 is equal to 4x plus 6 minus 69. Okay, finally, the equation got a little bit shorter. On the right-hand side, I can do 6 minus 69. So 5x plus 3 is equal to 4x minus 63. Okay, I'm going to move x's to the left, numbers to the right. Subtract 4x, subtract 3. So I'll have x equals negative 66. Notice it is an integer. Okay, now to get the next one, add 1, then add 2, then add 3. So x plus 1 will be negative 65, x plus 2 is negative 64, and x plus 3 is negative 63. There are the integers in correct order. Sometimes in one like this you'll be asked what is the smallest integer, in which case it's negative 66, or you might be asked what's the largest one, in which case it's negative 63. Let's try another. Find 3 consecutive even integers that satisfy the property that the sum of 1 more than twice the first, 4 less than 3 times the second, and 5 more than 4 times the third is 186. Okay, now again, the first time we read it, we're just looking to see, does it have the word even or odd? Okay, excuse me. I do see the word even. 3 consecutive even, so I'm going to add 2 every time. So x will be the first even integer, x plus 2 is the second one, and x plus 4 is the third even integer. So there are the names for my integers. Okay, here's my verb of being. Something equals 186. I'm going to have a 186 out here all by its lonesome. So I want the sum of 1 more than twice the first, 4 less than 3 times the second, and 5 more than 4 times the third. Okay, so this is where everything's coming from. Okay, these plus signs that don't have any color, they're coming from find the sum of something. Notice, these plus signs are actually acting like those commas. 1 more than twice the first, there's 1 more than twice the first. Remember, the first was called x. Right here is 4 less than 3 times the second, and this is 5 more than 4 times the third. Okay, now again, when we solve this one, because the problem said to find consecutive even integers, we better get an even integer as an answer. If we get an odd integer, that means the original problem had no solution, or if we don't get an integer at all, then that says the original problem had no solution. Okay, now again, our first equation that we've written down is rather long. Okay, let's get rid of the color. So I'm going to have to distribute the 3 and distribute the 4. So I'll have 2x plus 1 plus 3x plus 6 minus 4 plus 4x plus 16 plus 5 equals 186. Okay? So I've distributed the 3 and the 4. So So again, my equation is still rather long. I now want to combine some similar terms on the left. So if I combine my x's, 2x and 3x is 5x, plus 4 is 9x, so I got 9x. When I do my numbers, 1 plus 6 is 7, 7 minus 4 is 3, 3 plus 16 is 19, plus 5 is 24. So 9x plus 24 equals 186. Okay, finally the equation looks halfway decent. Subtract the 24. So 9x is equal to 162. Okay, here's our moment of truth. Divide by 9. Remember, I want something even. I get x is 18. It is even. So 18 is the first integer, x plus 2. 20 is the second integer, 22 is the third one. So there are my integers, 18, 20, and 22. Okay, don't put them in parentheses, don't put them in braces, don't decorate them. Number 3. Let's find 4 consecutive odd integers that satisfy the property that the sum of the first, 1/3 of the second, and 3 times the third is 1 more than 4 times the fourth. So I want 4 consecutive odd integers that satisfy the property that the sum of the first, 1/3 of the second, and 3 times the third is 1 more than 4 times the fourth. Now again, the first time you read it, you want to see does it have the word even or odd. I do see the word odd, so I'm going to be adding 2 every time. Okay, I want 4 of them. So I'm going to have x, x plus 2, x plus 4, x plus 6. Those are the name of my 4 odd integers. Okay. Here is my verb of being, that means equals. Okay, the right hand side will be, okay, 1 more than 4 times the fourth. So I want 4 times x plus 6 and then add 1 to that. Okay, this sum of the first, 1/3 of the second, and 3 times the third, that's going to be the left hand side. So x plus 1/3 times x plus 2 plus 3 times x plus 4. That's the left hand side. So again, this is where everything is coming from. Now, these plus signs, again, that have no color, notice those are the commas again. Okay, so the first, 1/3 of the second, 3 times the third, okay, 1 more than 4 times the fourth. Okay, again, our equation is rather long with the consecutive number problems. The very first equation you write down is going to be rather long, so get suspicious if it isn't. Then your second equation is also rather long, and sometimes the third one is as well. Okay, let's have the color go away. Now, I'm noticing a fraction, so the first thing I'm going to do is I'm going to multiply everything by 3. Now remember, when you clear fractions, do not go inside the parentheses. So I'm going to multiply everything that's outside of parentheses by 3. So I'll have 3x plus x plus 2 plus 9 times x plus 4 is equal to 12 times x plus 6 plus 3. So remember, everything that's outside of parentheses gets multiplied by 3 when we clear fractions. So we got 3x plus x plus 2 plus 9 times x plus 4 is equal to 12 times x plus 6 plus 3. Now it's time to distribute. I'll distribute this 9 and this 12, and I suppose technically I'm distributing 1 too. So I'll have 3x plus x plus 2 plus 9x plus 36 equals 12x plus 72 plus 3. So I've distributed. I've dropped my parentheses. Okay, I now need to combine terms on both the left side and right side. On the right side I'll have 75 there. See, on the left side I want to combine terms. 3x and x is 4x plus 9x is 13x. So I have 13x, and the number 2 plus 36, I get 38. So 13x plus 38 equals 12x plus 75. Okay, x is to the left, numbers to the right. Okay, subtract 12x, subtract 38. So I'm going to get x is equal to 37. It's odd, and that's what I wanted. So 37 is the first odd integer. The next one, 39. 41. And 43. There are my 4 consecutive odd integers. Again, if you were asked for the smallest, it's 37. If you were asked for the largest, it's 43. If you were asked for the third one, it's 41. So when you're doing the problems for tests, homework, and quizzes, read the directions carefully and answer only what is asked. Do not answer more and do not answer less. Let's go to our next category of word problems, the motion problems. Okay, motion as in something is moving. So for the motion problems, we need a formula. Okay, we need a formula. The formula is distance equals rate times time, or in using letters, d is equal to rt. Okay, we always call it rate, but rate is speed. Okay, so rate is speed. So note, negative time, distance, or rate does not make sense. So if you get a negative time, rate, or distance, check to be sure you've made no mistakes, and if you haven't made any mistakes, that means your word problem doesn't have a solution. So some examples. Okay, our first one. A freight train leaves Atlanta for Chicago at a rate of 30 miles per hour. 2 hours later, a passenger train leaves Atlanta for Chicago on a parallel track traveling 45 miles per hour. How far from Atlanta will the trains be when the passenger train starts to overtake the freight train? So notice I'm looking for how far from Atlanta. I'm looking for a distance. Okay, we're actually going to set up a little table to solve this. So we make a table. So I've got the freight train and the passenger train. I got distance, rate, and time. Now whenever you set up this table, typically what will happen, but not always, is one of the columns will have the exact same entry in both rows. Okay? So now, because we've written it as dRt, remember, each one of the rows will write an equation. D is equal to RT. Let's start filling some stuff in. A freight train leaves Atlanta for Chicago at a rate of 30 miles per hour. So I've got the rate for the freight train, 30 miles per hour. Okay, 2 hours later, a passenger train leaves Atlanta for Chicago on a parallel track traveling 45 miles per hour. Okay, so the passenger train is traveling at 45 miles per hour. Okay, now, somewhere in that sentence was something about time, 2 hours later. Notice that means the freight train has been on the track 2 hours longer. So the freight train has been on the track 2 hours longer than the passenger train. So, now the D's are the same, okay, because if the freight train and the passenger train are going to be having one passing the other, for one brief instant, they'll be the same distance from Atlanta. So when the passenger train starts to overtake the freight train, for one brief instant, they're the same distance from Atlanta. Now, the times. Okay, the freight train has been on the track 2 hours longer. So if the passenger train is T, then the freight train is T plus 2. Okay, now remember, each row writes an equation. So our first row says D is equal to 30 times T plus 2. The second row tells me that D is equal to 45T. Okay, and the problem is I got way too many variables. Now remember, these two are the same D. So that means that these two expressions have to equal each other. So I'm going to get 30 times T plus 2 is equal to 45T. You notice I'm going to get a value for time. I wanted a distance. So after I get that value for time, I can go back to either one of these two equations, whichever one looks easiest, and plug in that value for T to get the D. Now it shouldn't matter because I should get the same for both, so that's actually a check for us. Okay, so I'm looking at 45T equals 30 times T plus 2. Distribute the 30. So 45T is equal to 30T plus 60. Subtract 30T. 15T is 60. So I get T is 4. Okay, that's 4 hours. Now remember, we were looking for a distance. So go back to either one of these two equations and let T be 4. You should get the same result. I'm going to use this one because it looks easier. So the D is going to be 40 times 4, 180 miles. Notice if you plug it here, 4 plus 2 is 6, and 6 times 30 is also 180. So that's kind of our check. Now again, when you make this little distance, rate, time table, one of the columns will have the exact same entry for both rows. Number 2. 2 cars leave an intersection at the same time. Hopefully that little phrase, at the same time, kind of tells you which column has the same entry for both rows. One travels north and the other travels south. So they're going in opposite directions. The northbound car is traveling 10 miles per hour slower than the southbound car. If the cars are 360 miles apart after 3 hours, find the speed of each car. Now, when you answer, be sure you, like on a homework in my math lab, be sure you put down the correct speed for the correct car. Don't get them switched. So we're going to make our little distance, rate, time chart. So making our little table. Okay, I've got a northbound and a southbound. Okay, two cars are going to intersect at the same time. One travels north, the other travels south. Okay, the northbound car is traveling 10 miles per hour slower than the southbound car. Okay, we're comparing two things. Typically, but not always, whenever you're comparing two things, the one that's mentioned second is the unknown. So the southbound car is mentioned second. So the northbound car is traveling 10 miles per hour slower than the southbound car. So if the southbound car is R for rate, the northbound, okay, 10 miles per hour slower, R minus 10. Okay, now, they left at the same time, and they traveled for 3 hours. So the T is 3 for both of them, 3 and 3. Okay, now the distances, I don't know. Okay, call them D1 and D2 for lack of a better name. Okay, now, it can't be the same. Remember, they're traveling at different rates, so they can't be the same. But what we do know is that after 3 hours, they're 360 miles apart. Okay, now remember, each one of these rows writes an equation. So D1 is equal to 3 times R minus 10, and D2 is 3 times R. Okay, now remember, these D's are not the same. What we know is that the sum of the distances is how far apart they are. So D1 plus D2 has to be 360. Okay, so we're getting D1 plus D2 is 360. Because, again, they're 360 miles apart after 3 hours. Okay, replace these D's with their equivalent expressions. So 3 times R minus 10 plus 3R is equal to 360. And there's our equation. And notice, we're looking for rates. I'll be finding a rate. Okay, distribute this 3. So 3R minus 30 plus 3R is equal to 360. Combine 3R and 3R. 6R minus 30 is equal to 360. Add 30. 6R is equal to 390. You can divide by 6. R is 65. Remember, R was the southbound car. So 65 miles per hour for the southbound car. Remember, the northbound was R minus 10. So that would be 55. So 55 miles per hour for the northbound car. Okay, our next big category, I've always just called it the rope problems. Okay, the rope problems. Okay, here's the idea. Something, like a piece of rope, is cut into two smaller pieces. The sum of the smaller pieces is the whole piece. For simplicity, we always neglect any waste in cutting. Okay, when it's something like a rope, you can usually do that, but if you're like sawing wood or sawing hardwood flooring, you cannot neglect waste in cutting, because if you do, you're going to have a huge gap eventually. So again, the idea is the sum of the two smaller pieces is the whole piece. Now, negative lengths don't make sense. Some examples. A 42-foot long piece of rope is cut into two pieces, so that one piece is 6 feet shorter than twice the other piece. Find the length of each piece. Now, sometimes instead of finding the length of each piece, you'll be asked, find the length of the shorter one, find the length of the longer one. So again, read each problem carefully and answer what is being asked. Do not answer more than what is asked. Do not answer less than what is asked. If you answer more or less than what is asked, it gets marked wrong. Remember, reading and following directions is part of doing math. So, here's the picture of the problem. There's my rope. It's 42 feet long. Okay, that's what it says. Okay, I cut it somewhere, so maybe I cut it right about there. Okay, the piece on the left is, I don't know, call it X. But according to the problem, the other piece is supposed to be 6 feet shorter than twice that. So I want 6 shorter than twice X. 2X minus 6. Okay, now when you add up the two pieces, it's supposed to equal the whole. So X plus 2X minus 6 is equal to 42. Okay, the parentheses aren't really necessary. They just separate the two pieces of rope. So if I combine my x's, I'll have 3x minus 6 is 42. Okay, add the 6. 3x is 48. Divide by 3. Okay, x is 16. Okay, now the other, so that's this left-hand side. The right-hand side is 2x minus 6. So 2 times x minus 6 is going to be 2 times 16 minus 6, which is 32 minus 6, which gives me 26. Now as a quick check, the 16 and 26 add up to be 42. If they don't, something is wrong. So the lengths of the pieces of rope are 16 feet and 26 feet. Now again, if you were asked for the shorter one, 16 feet. The longer one, 26 feet. Let's try another one. An 88-foot long piece of rope is cut into two pieces so that one piece is 3/5 as long as the other piece. Find the length of each piece. So one is 3/5 as long as the other. So if we make a picture here, there's our rope. It's 88 feet long. I cut it two pieces, so maybe I cut it right about here. Okay, this piece is X. Okay, the other piece is supposed to be 3/5 as long as. Remember, two occurrences of the word as means multiply. So 3/5 X. Okay, when you add up the two smaller pieces, it's the whole. So X plus 3/5 X is equal to 88. Not a bad equation, just happens to have a bad number in it. Myself, I don't like to deal with fractions. My common denominator is 5. Multiply everything by 5. So I'll have 5x plus 3x is equal to 440. Combine the x's. 8x is equal to 440. Divide by 8. X is equal to 55. Okay, now this piece is supposed to be 3/5 times x. So 3/5 times 55. Okay, the 5 will go into 55 11 times. So you end up with 33. And do these two pieces add up to be 88? Yes. So the lengths of each piece is 55 feet and 33 feet. Okay, what can make the rope problem bad is the relationship that exists between the two pieces after you cut. Okay, that's the only thing that can make it bad. Our next category of word problems, rectangle and perimeter. Okay, now later on we'll look at rectangle and area, but this time it's rectangle and perimeter. Okay, that means we need to know the perimeter formula. So we need the perimeter formula. For a rectangle, perimeter is 2 lengths plus 2 widths. Okay, I'm always going to use L and W, the obvious letters, lengths and widths. So here's our rectangle. Length, length, width, width. Now, you can actually check your answer, because remember, after you get your length and the width, and you use this formula, you better get whatever the perimeter that's stated in the problem. Okay? Now, negative lengths and negative widths don't make sense. It's okay to have fractions. You may not like them, but it's okay to have fractions. And the perimeter, remember, is always the distance around the rectangle. Sometimes it's kind of disguised by talking about a fence around a corral or something. That's another way to disguise the perimeter problem. So, some examples. Okay, number 1 says, the width of a rectangle is 3 feet longer than half the length. Find the dimensions if the perimeter is 60 feet. So the width of a rectangle is 3 feet longer than half the length. Find the dimensions if the perimeter is 60 feet. Okay, this is typical of all the rectangle problems, whether it be rectangle in area or rectangle in perimeter. One of the sentences, and usually it's the very first, the very last, sets up a relationship between length and width. So our solution, this first sentence, width is 3 feet longer than half the length, right there. Width is 3 feet longer than 1/2 L. That's the relationship between L and W. So notice, if you find a value for L, you plug it in here, and that'll give you a W. So there's our relationship between width and length. Okay, after you've established the relationship that exists between W and L, write down, in this case, the perimeter formula. If we were doing area, we would write down the area formula. So remember, perimeter is equal to, so now I'm going to write the perimeter formula. Perimeter is equal to 2 lengths plus 2 widths. Okay, the technique that we're using is called substitution. We're now going to substitute values into what we know here. Okay, the perimeter of the P is 60. Length is, I don't know. But W, according to what's up here, W is 1/2 L plus 3. So I'm going to replace P with 60 and W with 1/2 L plus 3 into the perimeter formula. So now I'm going to substitute, and that's what's going on. So 60 goes for the P, 1/2 L plus 3 goes for the W. And you need to keep the 1/2 L plus 3 in parentheses. So 60 is equal to 2L plus 2 times 1/2 L plus 3. Okay, notice I don't really need to clear fractions because when I distribute the 2, it'll take care of itself. Now this is one of the few times that my unknown is on the right. Okay, the L is my unknown. I'm going to keep it on the right. So let's distribute that 2. So 2 times 1/2 is going to be 1. So I'll have L plus 6. So 60 is equal to 2L plus L plus 6. Combine 2L and L to get 3L. 60 is equal to 3L plus 6. Okay, again, I'm going to keep the variable on the right. So subtract 6. Okay, 54 is equal to 3L. Divide by 3. get 18 as L. Okay, we have L. Now remember, we said if we could find L, we'd go way back up here and replace L with the value to get W. So L is 18. So my width is going to be 1/2 times 18 plus 3. You get 12. Half of 18 is 9. 9 plus 3 is 12. So the length is 18. The width is 12 feet. You know, please don't write 18 by 12 or 12 by 18 because I don't know what that means. You have to tell me which is length, which is width. Okay, in my math lab, it'll have length equals or width equals. Please don't mix them up. And kind of as a quick check, if you look at 18 plus 12, you're going to get 30. That's half the perimeter, which is what it's supposed to be, because remember, you just looked at one length and one width. So there's kind of a way to check. Let's try another one. Now, how bad this comes down to is how bad is the relationship between W and L. Because remember, the perimeter formula cannot change. It's the relationship between W and L that can make it bad. So number 2 says, the length of a rectangle is 8 feet shorter than 3 times its width. Find the dimensions if the perimeter is 56 feet. So the length is 8 feet shorter than 3 times its width. And the perimeter is going to be 56. Okay, this first sentence, length of a rectangle is, so L equals 8 feet shorter than 3 times its width. So 3W minus 8. That's what that first sentence is telling us. L equals 3W minus 8. There's your relationship between L and W. In this problem, if we can find W, we'll be able to find L. Okay, now we're doing perimeter, so after you write down the relationship between L and W, write down the perimeter formula. So the perimeter formula is 2L plus 2W. Okay, now start substituting. I'll replace P with 56. I will replace L with 3W minus 8. And W is still W, I don't know. Now remember, keep the 3W minus 8 in parentheses. I'm going to have 56 is equal to 2 times 3W minus 8 plus 2W. So again, this is what I'm substituting. 56 for P, 3W minus 8 for L. And again, notice, the unknown is going to be on the right-hand side. So 56 equal to 2 times 3W minus 8 plus 2W. I'm going to keep the unknown, in this case it's W. I will keep it on the right-hand side. I need to distribute that 2. So 56 is equal to 6W minus 16 plus 2W. On the right-hand side, I need to combine my W's. 6W plus 2W is 8W. So 56 is equal to 8W minus 16. Keep the W's on the right, so add 16 to both sides. So I'm going to get 72 is equal to 8W. Divide by 8, 9 is W. Now that we have W, go back up here and replace W with 9 to get L. So L is going to be 3 times 9 minus 8, which is 19. 3 times 9 is 27. 27 minus 8 is 19. So the width is 9 feet. The length is 19 feet. And there's our perimeter. Okay, again, later on, chapter 3, as it turns out, we will look at rectangle and area. Our next category, mixture problems. Okay, mixture problems. This is one of the few places where decimals are natural. So we will have something like acid, antifreeze, alcohol, salt, etc. dissolved in a solution. Using acid, the basic idea is this. The acid you start with plus the acid you added is equal to the acid you end up with. Makes sense, right? What you start with, what you add, is what you end up with. Keep in mind that water is 0% acid or 0% antifreeze or 0% of anything other than water. That's how it gets to be pure water. Students often don't like the pure water problems, but they're actually easier because you have 0 times something, which means it just goes away. We will sometimes have money instead of acid, antifreeze, etc., in which case we're going to have this. The money you start with plus the money added is equal to the money you end up with. Okay, now notice percents are decimals. You always convert a percent to a decimal when you're working with it, and money is decimals. So the mixture problems are naturally going to be decimals. And sometimes you might have to round, so look at the directions to see if it says anything about rounding. If there are no directions about rounding and you think your answer needs to be rounded, you've done something wrong. let's look at a couple of basic examples, which are going to be the foundation for the worst ones. So some basic examples. Okay, number one says, how much alcohol is in a 40-liter solution that is 32% alcohol? Your answer may be a decimal number. So how much alcohol is in a 40-liter solution that is 32% alcohol? Okay, change the 32% to a decimal point 32. So the amount of alcohol is equal to concentration times volume. Okay, so the concentration is the percent. Okay, so the amount of alcohol is the concentration times volume. So it's going to be 0.32 times 40. Okay, you just take out your calculator and do 0.32 times 40, and you get 12.8. Okay, notice there's no need to round. It took care of itself. Okay, so it's 12.8 liters. So it's concentration times volume. Now, to do a money problem, find the total cost of 3 pounds of peanuts that cost $1.29 per pound. Okay, the total cost of 3 pounds of peanuts that cost $1.29 per pound. So the total cost is the cost per pound times weight. So cost per pound times weight. So it's going to be 1.29 times 3. Again, just take out your calculator and do 1.29 times 3. You get $3.87. Okay, so those are the basic examples. So notice it's going to be a concentration times a volume or a cost times a weight. And it is typically going to be decimals. So the previous two basic examples are what we'll use to find the amount of acid or amount of money when we use acid you start with plus acid you add equals acid you end up with, or money you start with plus money you add equals money you end up with. So a percent multiplies a volume, a money amount multiplies a weight. Now the money can also multiply volume if you're looking for like gasoline, the cost per gallon. So let's try the nastier looking problems. So some examples. Number one says, how many liters of 40% acid should be combined with a 30-liter mixture that is 15% acid in order to obtain a mixture that is 25% acid? Okay, this usually happens at a lab that uses acids a bunch of times. They eventually get different concentrations, and they want to be able to use what they have before they have to order more acid. So I'm going to let X equal the amount of 40% acid we add. Okay, so how many liters of 40% acid should be combined with a 30-liter mixture that is 15% acid in order to obtain a mixture that is 25% acid? So now the equation, acid we start with plus acid we add, what is it, and the acid we end up with, what does it become? The acid we start with, we're starting with a 30-liter mixture that is 15% acid. So I'm going to have 0.15 times 30. Remember, it's a percent times the volume plus the acid we add, 0.4 times X. The acid we end up with, okay, so it'll be 0.25, 25%, times 30 plus X. Okay, the volume on the right-hand side is always the sum of the two volumes on the right, on the left. We had 30 liters and X liters, so 30 plus X. Okay, notice we just have very bad decimals. I probably should not have used that time symbol. It looks like the X. So that's 0.15 times 30 plus 0.4 times X is equal to 0.25 times 30 plus X. Okay, now I did use a calculator to multiply the decimals. So I'm going to do 0.15 times 30, and I'm going to distribute the 0.25. So I end up with 4.5 plus 0.4x equals 7.5 plus 0.25x. I'm going to move x's to the left, numbers to the right. So I'll subtract 0.25x, subtract 4.5. Okay, 7.5 minus 4.5 is going to be 3. 0.4x minus 0.25x will be 0.15x. So 0.15x equals 30. Now divide by 0.15. So X will be 20 liters. You need 20 liters of 40% acid. Let's try to get it. Number 2. Susie wants to make a 50-pound mixture of nuts that will cost $2 per pound by combining peanuts that cost $1.25 per pound with cashews that cost $2.50 per pound. How many pounds of peanuts and how many pounds of cashews does she need? Okay, notice in this problem, unlike the previous one, we're told what the total weight is going to be at the end. We're looking for the weights in the beginning. Remember, when we got money, the money is going to multiply a weight. So let's see. I'm going to let X equal the pounds of peanuts. Remember, in the end, she's supposed to end up with 50 pounds of nuts. So if it's X pounds of peanuts, it's 50 minus X pounds of cashews. Okay, now let's see. So we're going to imagine that we start with the peanuts. Okay, so the money you start with plus the money you add equal money you end up with becomes this. Okay, we're imagining that we're starting with peanuts. So I'm starting with my peanuts, 1.25 times X plus 2.50 times 50 minus X equals 2 times 50. So cost per pound of peanuts times peanuts. Cost per pound of cashews times weight of cashews. Cost in the end times weight in the end. Notice this 50 really is X plus 50 minus X. It's still true that the weight on the right is the sum of the two weights on the left. Okay, I didn't put the 0 for 250 because it's not really going to matter. Let's now distribute the 250 and then do 2 times 50. So that'll be 100. That one was easy. I'll have 1.25x plus 125 minus 2.5x equals 100. Okay, on the left, let me combine my x's. 1.25x minus 2.5x, I get negative 1.25x. So 125 minus 1.25x is equal to 100. Let's subtract the 125. So I'll have negative 1.25x equals negative 25. Divide by negative 1.25. And you're going to get x is 20. And that was the peanuts. So you need 20 pounds of peanuts. The cashews, remember, is 50 minus x. So 30 pounds of cashews. So 20 pounds of peanuts, 30 pounds of cashews. Okay, if you're really ambitious, you can use this technique right here and octane ratings to see whether or not the price per gallon at the gas stations are really fair for the different grades of gasoline. Sometimes they are, but most of the time they're not. Okay, let's try one with pure water. So how many liters of pure water should be combined with a 20-liter mixture that is 40% acid to get a mixture that is 10% acid? So how many liters of pure water should be combined with a 20-liter mixture that is 40% acid to get a mixture that is 10% acid? This type of mixture problem that we're doing can also be used to look at trying to reduce pollution in an environment. You don't have to eliminate it, you just have to cut down on it. So let's see, the amount of pure water, let's call that X. Okay, so the acid you start with, that's going to be 0.4 times 20 plus the acid you add. Now notice, we're not really adding any acid. It would be 0 times X is equal to the acid you end up with 0.1 times 20 plus X. So 0.4 times 20, right? 20 liters, that's 40% acid. Okay, I did put 0.0, so that way it doesn't look like the word ox. And 10% times 20 plus X. Again, the volume on the right is the sum of the two volumes on the left. So 0 times X is 0, so do 0.4 times 20 and distribute the 0.1. So I'm going to have 8 is equal to 2 plus 0.1x. Okay, this one, there are no variables on the left, so I'm going to keep the variable on the right. So I'm going to subtract the 2. So I'm going to have 6 is equal to 0.1x. Divide by 0.1. 60 is equal to x. You have to add 60 liters of pure water. That's an awful lot of water. Let's do another thing where it's natural to use decimals. Money. Money and interest. So our next category, simple interest problems. Now in Chapter 5, we'll actually look at compound interest problems. So we need the simple interest formula. So again, it's a formula, so there's not a whole lot of variety. So I, that's an I for interest. I is equal to PRT. Or what do the letters stand for? Okay, I is the interest earned. P is equal to principal. It's the money invested or deposited or the money you borrow. R is the interest rate as a decimal number. So 5% would be R is equal to 0.05. And T is time in years. So that's the formula they're going to use. So we can't have a whole lot of variety. Let's try some examples. Okay, now I've tried to make the amounts of money so large that the dollar amounts end up being whole numbers in your final answers. So number 1 says, Susie has invested some money at 6% simple interest. She has invested $3,000 more than this amount at 9% simple interest. If the total interest earned from the two investments after 1 year is $1,020. How much was invested at each rate? Okay, now let's see. Susie has invested some money at 6% simple interest. So how much did she invest at 6%? I don't know. Call it X. So X is equal to the amount at 6% interest. She's invested $3,000 more than this amount. So X plus 3,000 is the amount at 9%. Okay, so these are acting like my two different P's in my interest formula, that I is equal to PRT. And of course, there's one of the R's, there's the other R. Okay, notice the time is 1 year. So the X and the X plus 3,000 play the roles of P. The X uses R as 0.06. The X plus 3,000 uses R as 0.09. Now, in both cases, T is 1. So remember, when I add up the interest, I'm supposed to get 1,020. So 0.06x plus 0.09 times x plus 3,000 is equal to 1,020. So the interest from the 6% investment, the interest from the 9% investment added together is 1,020. We need to distribute the 0.09. So I got 0.06x plus 0.09x plus 270 is equal to 1,020. Let me combine my x's. 0.06 plus 0.09 is 0.15. So 0.15x plus 270 is equal to 1,020. Subtract the 270. 0.15x equals 750. Divide by 0.15. X is 5,000. So she's invested $5,000 at 6%. So $3,000 more than that, X plus 3,000 is 8,000. So it's 8,000 at 9%. So she's invested $5,000 at 6% and $8,000 at 9%. Let's take a look at another. Number 2. Susie has invested some money at 7% simple interest and twice that amount at 12% simple interest. If the total interest earned from the two accounts at the end of 1 year is $992, how much was invested at each rate? Now, realistically, the reason this person might do this is they're trying to diversify their portfolios. Like, don't put all your eggs in one basket. Okay, now again, looking at the problem. Susie has invested some money at 7%. So how much? I don't know. Call it X. So X is equal to the amount at 7%. Twice that amount, so 2X, is at 12%. So again, here are my P's, and there are their corresponding R's. The time is, once again, 1 year. So when I add up the two interest earned, I should get 992. So my equation is going to be 0.07x plus 0.12 times 2x is equal to 992. The equation is actually a little bit simpler looking than the previous one. Okay, now I'm not distributing, I'm actually associating. I'm doing the 0.12 times 2, so I'll have 0.07x plus 0.24x is equal to 992. Okay, combining your x terms, 0.07 plus 0.24 is 0.31. So 0.31x is equal to 992. Now again, if you're not really swift with decimals, just take out your calculator and add up the decimals. Okay, divide by 0.31. So x will be 3,200. So she's invested 3,200 at 7%. Okay, twice that amount. 2 times 3,200, I get 6,400. And that's at 12%. So $3,200 at 7%, $6,400 at 12%. Our next big category of problems. Triangle problems. Okay, triangle problems. We need a little fact. To solve the triangle problems, we need the following fact. It's something that you may recall if you took high school geometry. The sum of the measures of the three angles of a triangle is 180 degrees. So when you're doing the triangle problems, you'll have first angle plus second angle plus third angle equals 180. And notice you'll also use that as a check. After you get your numerical values, add them up and see if you get 180. If you don't, you clearly have it wrong. Okay, now in problems that compare two or more things, typically, but not always, the item mentioned second in the problem is going to be x. So again, typically, but not always. So for the triangle problems, the angle mentioned second, okay, not necessarily the second angle, but the angle mentioned second is going to be x. Now when you answer them in the order of first angle, second angle, third angle. Or if it asks you for the largest angle, give the largest. If it asks you for the smallest, give the smallest. So again, read the directions of the problems carefully and be sure you answer the way you're supposed to answer. Don't answer more, and don't answer less. So some examples. The first angle of a triangle is 6 degrees smaller than 3 times the second angle. The third angle is 4 degrees smaller than the first angle. Find the measure of each angle. Okay, so the first angle triangle is 6 degrees smaller than 3 times the second angle. The third angle is 4 degrees smaller than the first angle. We're looking for the measure of each angle. Now, the first time you read it, you just want to figure out which angle is mentioned second. So the first angle of a triangle is 6 degrees smaller than 3 times the second angle. Okay, the second angle is mentioned second. It's x. So since the second angle is mentioned second, it will be x. Now, rereading that sentence, the first angle is 6 degrees smaller than 3 times the second. So I want 6 smaller than 3 times x. That's 3x minus 6. That's the first angle. Okay, 3x minus 6. Okay, looking at the second sentence, the third angle is 4 degrees smaller than the first angle. Okay, well, right here is the expression for the first angle. I want 4 smaller than that. So I'll have 3x minus 6 minus 4. So give it that color. So 3x minus 6 minus 4, that's the third angle. And for 3x minus 6, what's the name of the first angle? Okay, now we're going to have to eventually do the combination of minus 6 minus 4. I'm going to go ahead and do it now. So 3x minus 6 minus 4 becomes 3x minus 10. I mean, we've got to do it sooner or later. May as well do it now and get it over with. So 3x minus 10 is the third angle. Remember, the second angle is x. So let's write down the equation. Remember, the sum of the three angles is 180. So 3x minus 6 plus x plus 3x minus 10 is equal to 180. So first, second, third. The parentheses aren't really necessary. They just separate the three angles. Remember, it always adds up to be 180. Let's combine terms. So 3x and x is 4 plus 3 more is 7. Negative 6 plus negative 10, I get negative 16. Add 16 to both sides. So 7x equals 196. Divide by 7. Now, you may not like fractional angles, but there's nothing wrong with them. You can't have negative angles. And you can't have 0 either. If you have 0 degrees for an angle, you don't have a triangle. So dividing by 7, I get x is 28. So that's the second angle. Okay, now remember the first one is 3x minus 6. So 3x minus 6 is 3 times 28 minus 6. 84 minus 6, we get 78. And the third one, remember, is 3x minus 10. So 3 times 28 minus 10, 84 minus 10, I get 74. Now as a quick check, if you add up those three numbers, do you get 180? If you don't, something is clearly wrong. Now again, let's write them in order from as first, second, third. So it's going to be 78 degrees, 28 degrees, 74 degrees. You know, again, if you were asked for which one's the largest angle, that's the 28 degrees. That's the smallest angle. The largest angle is 78 degrees. Okay, so again, read the problem carefully to see what exactly are you supposed to answer. Remember, do not answer more than what is asked. Do not answer what is less than what is asked. Let's try one more. Okay, the second angle of a triangle is 5 degrees larger than 4 times the first angle. The third angle is 1 degree smaller than 3 times the first angle. Find the measure of each angle. So the second angle is 5 degrees larger than 4 times the first. Third is 1 degree smaller than 3 times the first. Find the measure of the angle. Now remember, the first time you're reading it, you just want to see who's mentioned second in the problem. That's going to be x. So let's see. The second angle of a triangle is the first angle. Okay, the first angle is mentioned second. It's x. So x is the first angle since it was mentioned second. Now looking at that sentence again, the second angle is 5 degrees larger than 4 times the first. So 5 larger than 4 times x. 4x plus 5. That's the second angle. Okay, the Next sentence says the third angle is 1 degree smaller than 3 times the first. Okay, the first angle is x. I want 1 smaller than 3 times x. So the third angle will be 3x minus 1. So we have the names of our angles. So remember, when you add them up, you're supposed to get 180. So the equation is x plus 4x plus 5 plus 3x minus 1 equals 180. Again, the parentheses just separate the three angles. They're not really necessary. So on the left, I'll combine terms. X plus 4x is 5. X plus 3 more gives me 8x. The constant, 5 plus negative 1, so I have 4. So I will have 8x plus 4 equals 180. Subtract 4. 8x is equal to 176. Divide by 8. X is equal to 22. So that's the first angle. Okay. The second angle is 4x plus 5. So 4 times 22 plus 5, I get 88 plus 5, I get 93. Okay, the third angle, 3x minus 1. So it's going to be 3 times 22 minus 1, 66 minus 1, you get 65. Now as a quick check, will those three numbers add up to be 180? If they don't, something is wrong. Now if I put them in order of first, second, third angle, it's going to be 22 degrees, 93 degrees, 65 degrees. Now again, if you were asked for the smallest angle, that's 22 degrees. The largest angle is 93 degrees. Okay, our last category of problems. It's more angle stuff. That's an I. Okay, complementary and supplementary angles. So complementary and supplementary angles. And this is complementary with an E, not with an I. If it's with an I, it's like, my, you look lovely today. So what do these mean? So number one, two angles are called complementary if only if the sum of their measures is 90 degrees. So something plus something is 90. Each angle is called the complement of the other. So if the angle is x, then its complement is 90 minus x. Number two, excuse me, both the angle and its complement must have their measures in the open interval 0 degrees and 90 degrees. So notice you can't equal 0, you can't equal 90. Okay, number two, triangles are called supplementary if only if the sum of their measures is 180 degrees. Each is called the supplement of the other. If the angle is x, then its supplement is 180 minus x. So now both the angle and its supplement must have their measures in the open interval 0 degrees to 180 degrees. So you can't equal 0, you can't equal 180. We actually need three examples. One that just contains the word complementary, one that just contains the word supplementary, and one that contains both words. So, some examples. Okay, number one says, find an angle whose complement is 5 degrees smaller than 2/3 of the angle. Okay, so find an angle whose complement is 5 degrees smaller than 2/3 of the angle. So if we're looking for the angle, so let x be the angle. Okay, it says complement. Remember, the complement is 90 minus x. Okay. Now, here's my verb of being. That means equals. So find an angle whose complement is. So 90 minus x equals 5 smaller than 2/3 of x. So 2/3 minus x. There's your equation. 90 minus x equals 2/3 x minus 5. And the color is telling you where everything came from. Okay, notice we do have a fraction in the equation, so I'm going to be clearing a fraction, so I'll be multiplying everybody by 3. So let's get the color away. Okay, clear of fractions. Again, multiply everybody by 3. So 270 minus 3x is equal to 2x minus 15. X is to the left, numbers to the right. Subtract 2x, subtract 270. So negative 5x is equal to negative 285. Divide by -5, and lo and behold, x is 57 degrees. So your angle is 57 degrees. Number 2. The supplement of an angle is 9 degrees smaller than twice the angle. What is the angle? So the supplement is 9 degrees smaller than twice the angle. Find the angle. Notice, we're looking for the angle. I don't know what it is. Call it x. Okay, I've got something about the supplement. So if the angle is x, remember the supplement is 180 minus x. So there are the names of our players. Now, here's our verb of being that means equals. So the supplement of an angle is, so 180 minus x equals 9 smaller than twice the angle. 9 smaller than twice x, 2x minus 9. So there's where everything came from. Notice we don't have any fractions, so there's no clearing of fractions to worry about. Okay, let's get the color to go away. So my equation is 180 minus x equals 2x minus 9. X is to the left, numbers to the right gave me negative 3x equals negative 189. Divide by negative 3. X is 63 degrees. That's our angle. Okay, I got one more example. Number 3. Find an angle whose supplement is 12 degrees larger than 3 times its complement. So I want an angle whose supplement is 12 degrees larger than 3 times its complement. Now do notice, I want to find an angle. Call it x. I see both words, supplement and complement. So the complement, remember, is 90 minus x. The supplement is 180 minus x. So 90 minus x is equal to the complement. 180 minus x is equal to the supplement. I need both because both words are in the problem. Here is the verb of being that means equals. So supplement is 180 minus x equals 12 degrees larger than 3 times its complement. So I need 3 times 90 minus x plus 12. There's my equation, and that's where everything came from. Okay, we're going to need to distribute this 3. Okay, so we're going to need to distribute the 3 in order to solve the equation. So again, I got 180 minus x is equal to 3 times 90 minus x plus 12. So there, got rid of the color. Distribute the 3. So 180 minus x is equal to 270 minus 3x plus 12. On the right-hand side, I can combine the 270 plus 12, so I have 180 minus x is equal to 282 minus 3x. See, x is to the left, numbers to the right. So add 3x, subtract 180. So I'll have 2x is equal to 102. Divide it all by 2, and x is 51 degrees. So our angle is 51 degrees. Okay, now again, on tests, quizzes, homework, which word problems you get is just a matter of the luck of the draw. Between the Part A and Part B homework in my math lab, I've tried to give you at least one problem of each one of the types of word problems that we had so that we can at least practice on each one. Okay. That's the end of section 1.5.